welcome to this deep dive. Today, we're looking at something really quite beautiful and, well, profound. How sound and motion can actually organize themselves into structure.
Yes, it's like peeking into what some are calling a motion renaissance. This idea that motion isn't just random, it's maybe the root of, well, everything we see.
And a fantastic example, just visually stunning, is the Chladni plate experiment.
Oh, absolutely. It's so simple on the surface, isn't it?
Yeah.
But it shows so much about how motion creates form, almost like right before your eyes.
Exactly. So for anyone who hasn't seen this, you basically take a flat plate. Could be metal, glass, whatever shape, really.
Yep. And sprinkle something fine on it, like sand or salt works too.
Then you make it vibrate. You can use a violin bow on the edge, which is the classic way, or maybe put a speaker underneath playing a specific tone.
And the magic happens. The sand. It doesn't just fly off randomly. It organizes itself into these incredibly precise, beautiful geometric shapes.
The Chladni figures, yeah. And physics, the standard explanation talks about standing waves.
Right. You get these areas where the vibration cancels out the nodal lines, and the sand just gets sort of shuffled away from the vibrating parts and settles where it's calm.
Makes perfect sense within that framework. Solid explanation.
It is. It definitely describes what happens. But today, we want to look at it through a slightly different lens. What we're calling motion theory.
Okay, interesting. So let's get into that. What does motion theory bring to the table here? What's the different perspective on these Chladni plates? What are we hoping to uncover?
Well, the goal isn't just to see it as, waves making sand move. It's to understand it as a demonstration of something deeper. How structured motion, right down at the fundamental level, actually builds order and shape.
So motion as the cause, not just the effect.
Exactly. Seeing motion as the architect.
All right. So where does motion theory start? With the plate itself, you call it a structured motion field. What does that mean?
Okay, yeah. The first point is crucial. Nothing is ever truly static. That metal plate, it looks solid still, but zoom way in, down to the atoms.
And they're all vibrating, moving around.
Constantly. Like a busy city of atoms, all with their own energy. That entire system, that inherent activity, that's the structured motion field.
Okay, so it's already dynamic.
Right. So when we vibrate the plate with a bow or speaker, we're not imposing motion on something inert. We're introducing a new energy flow into this already bustling arena. It becomes this arena of motion interactions.
Got it. And you also mentioned that different parts of the plate transmit energy differently. Does that matter?
Oh, hugely. The plate isn't uniform in how it handles that energy. Think about its density, its shape, tiny imperfections, the material itself.
Right, like different zones react differently.
Exactly. Some areas might pass the motion along easily, others might dampen it. Motion theory sees the surface as this playground for loop stabilization. Little whirlpools or patterns of motion can naturally form and sustain themselves based on the plate's own inherent structure.
Okay, the plate is buzzing with activity. Now, the sound. The vibration source. Motion theory calls it a sync pulse, a rhythm, not just a wave. Why that specific term?
It shifts the focus. A wave often implies this continuous flow. Sync pulse emphasizes the timing. Think of it like a drum beat. A specific rhythm, a series of precisely timed pushes or energy inputs.
So it's less about a constant pressure and more about a rhythmic signal, like tapping out a beat.
That's a good way to think about it, yeah. It's a temporal pattern. And this beat, this rhythm, then interacts with all the existing rhythms, the little motion loops already happening inside the plate.
So it's not just interference in the classic sense of waves canceling?
Well, that happens, but motion theory frames it as harmonic convergence. It's like when the incoming beat from the sound finds resonance, finds harmony with the plate's internal timings.
Like musicians locking into the same rhythm.
Exactly. The motion patterns settle into stable, synchronized arrangements because their timings align. It's a convergence, not just a cancellation.
That feels like a richer explanation. Okay, so what about the sand? It's called a structure tracking medium. What structure is it tracking?
It's tracking those areas of, let's say, minimal conflict. The nodal lines, yes, but why it gathers there is key. It's not just passively pushed. Remember, the sand grains themselves are tiny systems.
Right, molecules, atoms, also in motion.
They have their own internal rhythms, too. The vibrating plate creates these zones of high motion stress, lots of jostling, and unresolved energy.
Okay, chaotic areas.
Kind of. And the sand grains, well, they naturally tend towards stability, lower energy states, so they get effectively excluded from those high-stress areas.
So they run away from the chaos?
In a manner of speaking, yes. They migrate to where the plate's motion has found a kind of local equilibrium, where the different motions have largely canceled each other out through phase interference. They're essentially seeking shelter in synchronized voids.
Synchronized voids, I like that. So the stillness isn't just nothing happening.
It's more like the absence of unresolved rhythm. For that specific frequency, the different motions have found a way to balance out, creating these relatively calm zones where the sand can settle.
Okay, this is building a really interesting picture. Let's go a bit deeper on nested loops. The plate has atomic loops, the sand has molecular loops. How does the sound, the sync pulse, tie all these levels together?
Right. Think of it in layers. You've got the plate, this huge network of connected atomic loops, all vibrating, interacting. Then you have the sand grains, smaller clusters of molecular loops, again with their own vibrations.
Different scales of motion.
Exactly. And the sound comes in as this external timing pattern, this rhythm. It influences the atomic loops, which then affects how the molecular loops of the sand experience the surface. It's a rhythm affecting rhythms affecting rhythms.
So it's not just one layer of vibration, it's like a conversation across scales.
That's a great way to put it. It's a multi-layered sync negotiation. What we see, the pattern, is the outcome of all these different levels of motion, finding a common ground, a synchronized state.
So it really is motion resolving into geometry, not just vibration pushing stuff around.
Precisely. It's about how motion organizes itself when given a coordinating rhythm.
Wow, okay. And you hinted this isn't just a cool lab trick. This principle, motion resolving into structure, you see it elsewhere, these cosmic implications.
Oh, absolutely. It seems to be everywhere once you start looking for it. Think about something like crystallization.
Like salt crystals forming.
Yeah, or snowflakes. You have individual atoms or molecules, each moving, bumping around. But under the right conditions, their motions synchronize, they lock into place, forming these incredibly ordered geometric structures. That's motion resolving into form.
Okay, that fits. What else?
Well, think biology. Protein folding, these long, wiggly chains of amino acids.
Uh-huh.
They have to fold into very specific 3D shapes to work properly. What drives that folding?
Yeah.
It's all about the interplay of forces, energy, which is fundamentally motion, guiding the chain until it finds its stable functional form. Again, motion-finding structure.
And you mentioned even bigger scales, galaxies.
It's a bit more abstract, maybe, but yeah.
Yeah.
Think of the immense gravitational interactions between stars in a galaxy. That creates a kind of underlying rhythm, a pattern of potential.
Like a gravitational beat?
Sort of, yeah.
Yeah.
And that rhythm shapes the overall movement, guiding stars into those beautiful spiral arms. It's structure emerging from organized motion on a colossal scale.
And brainwaves, too.
Definitely. The rhythmic firing of millions, billions of neurons synchronizing across different parts of the brain. Those synchronized electrical patterns are the brainwaves we measure. That's coherence emerging from neural activity, from motion.
Even how embryos develop. Morphogenesis.
Yes. The incredibly complex process where cells divide, move, communicate, signal. It's a highly orchestrated dance of cellular motion and synchronization that builds the form of an organism. It's all motion coordinating to create structure.
So the Chladni plate isn't just an anomaly. It's like a little tabletop model of a universal process.
That's the perspective motion theory offers, yes. It's elegant proof that when motion finds ways to synchronize, structure isn't just possible, it's almost inevitable.
Okay, so let's try to distill this. What's motion theory's final verdict on the Chladni plate? The core takeaways.
All right, let's summarize. First, sound isn't just a wave pushing things. It's more like a rhythmic invitation. It offers a beat for the system's inherent motion to potentially lock onto.
Okay, invitation, not just force.
Second, matter itself isn't fundamentally static. It's better understood as a stabilized loop, a persistent pattern of dynamic motion.
Motion is what it is, not just what it does.
You could say that, yeah? And third, shape, the geometry we see emerge. That's basically what happens when motion learns to get along. It's the result of different scales and types of motion finding coherence, finding stability together.
Learning to get along. I like that. Makes the patterns feel less like an accident and more like a resolution.
Exactly. So the Chladni plate experiment stops being just a demonstration of wave physics.
And becomes more like a ceremony of coherence.
Precisely. A visible ritual showing how fundamental motion can self-organize into beautiful, stable forms.
So wrapping this deep dive up, the big takeaway really feels like this idea that the world isn't made of static things that sometimes move, but rather it's fundamentally made of motion that sometimes stabilizes into the forms we perceive.
From sand grains to galaxies, yeah. It's motion syncing with motion, layer upon layer. It definitely shifts how you might look at, well, almost anything.
It really does, and maybe that leaves us, and you listening, with a final thought to chew on.
Go for it.
Well, if this principle holds true, this idea of underlying rhythms and motions shaping form, think about other areas of your life, maybe social dynamics, group behaviors, even your own personal habits or routines.
Interesting extension.
Could there be unseen rhythms, patterns of interaction, patterns of motion, essentially, that are quietly shaping the structures in your life? What Chladni figures, what stable patterns might be forming around you or even within you that perhaps you haven't really noticed before? Something to ponder.